when they ask us to write this polynomial in standard form, that means that they want it to be x to the third plus 2x squared, all that stuff. Okay, so we got to multiply these out. And you could start by multiplying these two parentheses, but you can make your life easier by multiplying these two because they're conjugates. We're going to see things cancel out. And before we get too far in it, I squared is -1. Remember, that comes from our first discussion on imaginary numbers. So we'll use that at some point here. Okay, so I'm going to multiply these two things together. So you could use your box method if you know what that is. You could use FOIL if you know what that is. Just multiply these two parentheses together. I like to draw arrows to make sure I match up the term in the first parentheses with each term in the second parentheses. So x times x is going to give me x squared. X times square root of 3i is square root of 3ix. And then negative square root of 3i times x is negative square root of 3ix. And then negative square root of 3i times positive square root of 3i. Square root of 3 times square root of 3 makes 3. Okay, and if you want to check yourself, look, square root of 3 times square root of 3, you can multiply inside the radicals because they're both square roots. And the square root of 9 is 3. Right? Okay, so here, I haven't finished this term. I'm multiplying this one times this one. I got negative square root of 3 times square root of 3 makes -3. But I have an I times an I. That makes I squared. Right? So there's a bunch that we can simplify before we start multiplying again. Keep that x plus 2 here. X squared can't combine with anything, no like terms, but these cancel each other out. It's something subtracted by itself, so that makes 0. And this is -1. So -3 times -1 makes a +3. So look at that. All that mumbo jumbo just turned into this. And now we can multiply these two parentheses and we're done. So x times x squared makes x to the third. X times 3 makes 3x. 2 times x squared makes 2x squared. And 2 times 3 makes 6. So in descending powers, this is our polynomial in standard form. And that's it. Okay, so I pulled up another one that's kind of longer. So look up here, we multiplied the imaginary numbers and it made a bunch of cool stuff cancel out. Well, cool to me, not cool to a normal person, I guess. So we can multiply these things together because they have an I in them. Now, there's 3 terms in each parentheses, but we can still multiply them with that method I was using, or if you know what the box method is, you could use that. But you'll want to multiply the terms with I in them because that can usually make something cancel out. Okay, so I'm doing x times x makes x squared. X times -1 makes -x. And then x times I makes ix. Now I've got to multiply this times every term over here. So -1 times x makes -x. -1 times -1 makes +1. -1 times I makes -I. And then -I times x makes -ix. -I times -1 makes a +I. And -I times +I makes -I squared. Now I'm done multiplying those together. Okay, so there's a bunch we can cancel out. X squared doesn't have any like terms. So let's see. I've got -x, -x. Oh, maybe this one doesn't cancel out super nicely. Well, those don't. So -1x subtracted by 1x, you're going further back in the negatives. That's -2x. You've got ix minus ix. Those can cancel out. And I'm just going to scratch out what I've already taken care of. I've got -I plus I. That makes 0. And then this is I squared, so -1. This is a -1. So that means a +1. So you've got 1 plus 1. That makes 2. Okay, a lot simpler though, right? Now I guess we can multiply these two parentheses. So x needs to multiply to each term. That makes x to the third minus 2x squared plus 2x minus x squared plus 2x minus 2. And then -2x squared minus x squared, we're going further back in the negatives. So I've taken care of that, taken care of that, taken care of that. Plus 2x, that makes 4x. and then minus 2 at the end. Almost done. Now we just need to distribute that x to everything. So here it is in its glorious polynomial form. There we go.